Hello everyone, this is Jason. This chapter we will introduce the finishing operations and the parameter settings in 3x. The first part is overview of 3x finishing parameter settings, and the second part we will introduce the finishing operations and relevant parameter settings. Let's start with the first part, is the overview of 3x finishing parameter settings, because most of the parameters in finishing operations are the same as them in roughing. So in this chapter, we will introduce the different ones in different finishing operations. The different parameters are more located in limiting, tolerance, and step and pass settings. And next, we will introduce the different finishing operations and their exclusive parameters. Let's start with the lace operation. If you create a group of parallel toolpaths in XY plane first, then project them to the surface of the part, which is suitable for the finishing of shallow regions. The parameters we will introduce are containment type. It has three types: silhouette, simple box, and cut contact. It defines the different boundary types for the toolpaths. Please check the toolpath effect in the table, and please note that the toolpath conditions corresponding to the above containment types are only generated with the part feature. Percentage offset, when the operation has contained profile feature. This option will specify the containment offset value by the percentage of the tool diameter. Rough behavior and max cut depth is to specify whether to generate multi-layer toolpaths for roughing and set the max cut depth. And the next parameter in limiting is angle range, is to define the angle range to generate the lace toolpaths. And the next is path setting in lace operation. First is cut direction. You can check the toolpath effect in this table: zigzag, top to bottom, bottom to top, left to right, and right to left. And for climb and conventional types, we have introduced in 2x tutorial. And next is the cut angle. Is the angle between the toolpaths and the positive direction of the x-axis. The range also determines the start point, shown as below. And the last one in lace operation is the corner radius, is to add a fillet in vertical toolpaths with a specific radius. Now let's go to ZW3D and check these parameters. First is the features condition. If only with the part feature, it will generate the toolpaths on all surface that is not perpendicular to XY plane. If you want to generate in a specific area, just add a contain profile to the feature. For the containment type, silhouette and simple box is same as the one we introduced in limiting parameters of 3x roughing. Here we can check the effects. And cut contact. For this transition arc surface, ZW3D will calculate the contact point between the tool and the surface endpoint, then generate the toolpath can complete the machining of the entire transition surface. We can put on the tool and check the effect. And next is the percentage offset. Now is 0. Then we change it to 30%. Then the toolpath will offset 30% of the tool diameter from the contained profile. Basically, finishing operations will only generate one layer of toolpaths. However, the rough behavior option can control whether to generate multi-layers. Just turn on this option, and then max cut depth can set here. And then is angle range. Take these two paths as an example. For complete processing, we need to enlarge the angle range. Now it is 0 to 30 degrees, and I change it to 60 degrees. Let's check the two paths. And next is the path setting. Because the cut direction, we have listed all the two path effects in the PowerPoint, so we are not going to repeat here. And next, cut angle. It is the angle between the two paths and the positive direction of XX. Like now is 45 degrees and 135 degrees. Please also note that when changing the cut angle, the start point of the two paths will be changed also. All the situations, please refer to the PowerPoint. And the last one, the corner radius. In order to avoid the drop in the Z direction, we can set a corner in Z direction, for example, 2 mm. The two paths will transfer smoothly. Now let's back to the PowerPoint. Next operation is offset 3D. Based on different feature situation, if we generate two paths with unit 3D step over following by the silhouette or 3D boundary profile. In the tolerance and steps tab, number of cut is used to set the number of two paths generated from the boundary. If it is blank or 0, it will generate complete two paths. And percentage first step is to set the first step over value by percentage of the step over value. And path pattern. From boundary and toward boundary, you can check the images in this table. And percentage smoothing is to set the smoothness of the two paths at corners. Now let's go to ZW3D and check these parameters. First is also the feature condition. Only with part, the two paths pattern will follow the silhouette profile. If it has part and contain profile, it will follow the contain profile. Then next, I will introduce the number of cuts. Like now it is 3. If it's blank or 0, ZW3D will generate a complete two paths within the profile. And the percentage first step. Now the step over value is 1 and 100% first step. And if I change it to 50%, now let's check the first step. It should be 0.5 mm. Then next will be the path pattern from boundary and toward boundary. It will change the start point of the two paths. For example, I change it to toward boundary. The engage point will be inside the workpiece. And the last one, percentage smoothing, is to control the smoothness of the arc two paths. See the difference between 0 and 100%. Then we back to the PowerPoint. The next operation is angle limiting. It's a composite operation which will assign proper two paths to regions that are distinguished as steep or shallow by the steep angle value. First is flat and steep pattern. They are used to define the two path pattern in flat and steep regions. Lace, offset 3D, and HSM lace for the flat regions, and only the level for steep regions. In order to get a better surface quality, mean step down value can set a minimum step value in the direction. Check the effect here. Then next, we will introduce the path setting options for angle limiting operation. As I mentioned just now, angle limiting will assign proper two paths to regions that are distinguished as steep regions or shallow regions. Then steep angle option here is used to distinguish the steep or shallow regions. The regions where the angle between the surface normal and dx greater than the value will be assigned as steep regions. The opposite is shallow regions. Then cut regions is to control whether to cut flat regions or steep regions only, or cut all regions. And cut order, you can choose flat or steep first. And overlap can set the overlap size of the two paths between the flat region and steep region. Now let's go to ZW3D to check these parameters. First is also the feature conditions. This case, we add a contain profile to limit the toolpaths. We can hide unnecessary toolpaths to make it more clear. First is the steep angle. If we change it to 20, the toolpath will go a bit lower, because this option is used to distinguish the steep or shallow regions. And cut regions now is all regions. If I change it to flat region, it will only generate toolpaths on flat regions. And cut order now is flat first. We need to show all toolpaths. Then verify. It will process the flat region first. Then overlap now is 0.5. If we change it to 1, ZW3D will enlarge the overlap area. Then we switch to tolerance and steps. Toolpath patterns for steep and flat regions. Only the level for steep regions. And for flat regions we have lace, Offset 3D and HSM lace. For example, we can check the effect of Offset 3D. Then the last one is mean step down value. Take a look at this case. The step down value for steep region is 1 mm, but in the transition area, the toolpath will not maintain uniform. Then we can set a minimum step down value, for example 0.2. On the transition area, we generate more toolpaths. Then we back to the PowerPoint. The next operation is corner finish. It will detect the rest material in corners left from the reference tool specified by the user. Then generate the cleanup toolpath. It also has different toolpath patterns in flat or steep regions, along and across. And the steep cut progress, high to low or low to high. And next is the flat finish operation. It's applicable for the flat region machining. First, we will introduce the path type in Path Setting tab. Lace and Offset 2D. The toolpath pattern are shown as below. Then is Ignore Hole TDU. It's useful when the flat region has some holes on it. It can set a threshold value to define which hole to be ignored. If the ratio of hole diameter to tool diameter is less than the set Ignore Hole TDU value, ZW3D will ignore the holes, then generate the toolpath on it. Conversely, ZW3D will consider the hole and avoid it. Please check the effects in this table. Then outside in option is to set whether the toolpath can pass the boundary. Then sign finish is to set the distance between the cleanup toolpath and filling toolpath. It will appear only when the outside in is yes. Then the last one, bottom finish. It will define the bottom rest material. ZW3D will generate two layers of toolpaths. The first layer to get the specified rest material, then the second layer to clean up. Now let's go to ZW3D and check the corner finish operation and flat finish operation. First, we will introduce the feature condition of corner finish. We can simply use the part as feature and set reference tool. ZW3D will detect the rest material at corners based on the reference tool. For example, this case, we use 10 mm ball end mill, and this is the toolpath. And of course, if you want to process the certain area, you can add a contain profile to the feature. And the different toolpath pattern. This is across, and this is along. And different cutting progress, high to low or low to high. We can use verify to check. This is the effect of low to high. And next will be the introduction of flat finish operation. We also introduce the feature condition first. We can simply use part as feature. ZW3D will detect all flat surfaces and generate toolpaths on them automatically. Another way, we can use flat region. We can create a flat region, select the whole part. It will also detect the flat regions automatically and calculate. Then last way, we can create profile. Then in the input type, we use surface. We can select the specific surface that we want to generate toolpaths on. For example, this one. Then calculate. And the different path type now is lace. And this is the effect of offset 2D. And next one would be the ignore hole TDU option. In this case, the hole diameter is 20 mm and the tool diameter is 10 mm. So the ratio is 2 between them. And the set ignore hole TDU is 1.8 here. Based on the logic of this parameter, ZW3D will consider the hole and avoid it. This is the toolpath effect. Conversely, if I change the value to 2.5, that means the ratio between the hole diameter and the tool diameter 2 is less than this ignore TDU value. So ZW3D will ignore the holes and generate toolpaths on it. This is the effect. And then next two are outside in and side finish. The default setting of them are yes and 0.1. So the toolpath will pass the boundaries on open sides. And the distance between cleanup toolpath and filling toolpath is 0.1 mm. And the last one is bottom finish. In this case, we set it to 0.5 mm. Let's check the toolpath. It will generate two layers. The first layer will get the specified rest material. Here is 0.5 mm thickness. Then the second layer will remove the rest material to get the finished surface. Okay, then we back to the PowerPoint and introduce the next operation. Drive curve. It projects the guiding profile on the model to generate the toolpath, and it enables to offset the profile in both sides to generate the toolpath by defining the number of cuts. The number of cuts we mentioned just now is to set the number of toolpaths generated by offsetting from the guide profile. If it is empty, ZW3D generates the toolpaths along with the guide profile. Otherwise, it will generate the toolpaths on both sides with the set number. If we want to make the toolpaths within the guide profile, we can add a contain profile to the feature. And next one is pencil XY range. It's used to specify the value to enlarge the detecting area for generating the toolpath guided by the drive curve when the distance between the drive curve and the walls of the part is smaller than the cutter's radius. Now let's go to ZW3D and check. Firstly, it's the feature condition. We need to specify a profile as the guiding line. ZW3D will project it on the model and generate the toolpath. Then regarding the number of cuts, if it is blank or 0, it will only generate the toolpath on the guiding line. If we set a specific number like 3 here, then ZW3D will generate the toolpath on both sides based on the step over value. What if we want the toolpath within the profile? We can create one more profile, but the type should be contain. Then calculate. You see the toolpath is within the specific profile. And if we want the first toolpath is exactly on the profile, we can set the first step to 0. And the last parameter of drive curve is pencil XY range. Now the tool is 10 mm diameter. We select this profile as feature because the profile is too close to the walls of the model, so it can not generate the toolpath on the bottom of the wall. Then we can set the pencil XY range to enlarge the detect range. And this is the effect. And next, let's back to the PowerPoint and introduce the J level operation. It generates a set of contour toolpaths in J direction, which is suitable for the finishing of steep region. For the limiting parameters, it can limit the toolpath on the part with limit on part option. For the tolerance and steps, non-uniform cuts is to define the different step down for non-uniform cut to achieve uniform surface finishing. It has 3 options. No means turn the option off. Boundary point, if you define the regions by the boundary points, which can set different step down value. And drive curve will generate the toolpath according to the given max 3D step on the drive curve. We will explain more in ZW3D. And for path setting, the progress is to set the machining order. You can know it intuitively through these images. Start point is to set the lead in point, and corner control is to set the toolpath pattern at corners to be round, extend, or deloop. Now let's go to ZW3D and explore more. We can simply add the parts to the feature. It generates a set of contour toolpaths in Z direction, and of course we can limit the toolpaths by top and bottom point, and also add the specific area in XY plane with contain profile as before. I will not repeat the step here. And next I will introduce the limit on part option. This is the effect without and with this option. Obviously, with limit on part option, it will reduce a lot of extra toolpaths to save machining time. And next will be the non-uniform cut option. Let's see, this is the effect without using this option. In the Z direction, it will maintain the uniform step down value. For a better surface quality, we need dense toolpaths on the shell area, so we can use boundary point. Select a point on the model, then set a step down value for the area below the boundary point. Add layer, then calculate. Then check the toolpath effect. Actually, its logic is quite similar to the non-uniform cast parameters in parameter setting in 3x roughing. And another option in non-uniform cut of Z-level is drive curve. Check this example. We use Z-level operation to process this surface, but when the toolpath transitions from the vertical to flat, the toolpath cannot maintain uniform. To ensure the surface quality, we can use drive curve. Like select this curve, then set a max 3D step value, then calculate. Then the toolpath is more uniform now. And for the parameters in path setting, the progress, start point, and corner control. The introduction and pictures on the PowerPoint is very intuitive, so I won't go into the details here. Then we'll back to the PowerPoint, introduce the next operation, pencil cut. Like corner finish is also an operation for corner finishing. It will detect and generate a single trace toolpath to clean up the corners when its radius is equals or less than the tool radius. If we want to generate multiple toolpaths, we need to set a number of cuts value. And next one is the flow 3D operation. It will generate a set of uniform 3D step over toolpaths by morphing a pair of guide profile. Please note that guide profiles can be opened or closed. Start point and the direction of guide profile should be coincident, and two guide profiles should be separated. Now let's go to ZW3D and have a look. First is the pencil cut operation. We can simply add part to the feature. ZW3D will detect the corners when its radius equals or less than the tool radius. Now it is 2. And for the number of cuts, I will show you the default situation first. When it is blank or 0, it will only generate one toolpath. Then if we want multiple toolpaths, set a specific number, like 3 here. It will generate 3 loops of toolpaths based on the default ones. Then is flow 3D operation. In this operation, we need to add part and profile to the feature. In the profile, it should contain a pair of guide curves, and the start point and the direction of the guide curves should be coincident. Then this is the toolpath effect. Then we back to the PowerPoint. Next one is bounce operation. It will generate a network of bounce on the surface with 2 interesting curves. One is defined as the drive curve, directrix. The other as the generator curves, generatrix. The parameters we normally use is generatrix and directrix step. It's used to set the step over value along generatrix and directrix direction. Depth of bounce is to set the depth of every bounce cut, and noise XYZ. Toolpaths will offset randomly according to this value. Then the last one is engage 2D operation. It will generate the toolpaths according to the text silhouettes and project them to the model. Please note that it only engraves for the hollow text. The depth determines by the outline wireframe width of the text. And percentage max distance is to set the step over by the percentage of the tool diameter. Now let's go to ZW3D to check these 2 operations. For the bounce operation, the first profile here is defined as the drive curve, that is directrix. The second one is generator curve, that is generatrix. And the intersection point of the directrix and generatrix is the origin to array the toolpaths. And the depth of bound is here, and noise XYZ value, like we make it 10. The toolpath will offset randomly. The last one is engrave 2D. It can only engrave for hollow text, then generate the toolpath on the model. The percentage max distance is to set the step over by the percentage of the tool diameter. Let's check the difference. The depth is determined by the outline wireframe width of the text. Let's use solid verify to check the effect. We will see that the wider the text frame, the greater the cutting depth. Okay, that's all for the introduction of finishing operations and parameters in 3X. Thank you.